All right, welcome everyone. So, in this chapter so far, we've talked about how to graph polynomials, and now we're going to talk about how to graph rational functions. So, the word rational has a root word ratio, and we've kind of talked about this before. A ratio means a fraction. So, when we say rational functions, we know that our functions are going to be fractions. So, if you go and you look at some of the things that I've got going here, right? You can see that indeed this function is a fraction. And to get more detailed, I mean, technically a rational function is a polynomial on top of a polynomial. The things that we're going to be looking at won't have like square roots in them. That's not a polynomial. They won't have absolute values in them. That's not a polynomial, okay? So the types of things that we're going to be looking at need to be a polynomial, stacked on top of a polynomial. Okay, so let's go take a look at some more of them. So this is a polynomial. It's a linear polynomial because it's degree 1 on top of a linear polynomial. Here's some great examples. A linear polynomial on top of a quadratic, degree 2. Linear on a quadratic. Even a constant is considered a polynomial. It's a polynomial of degree 0. So a degree 0 polynomial on top of a degree 2. Okay. So you can see how all of these are going to look, their form. All right. So that's what a rational function is. Okay. And now we're going to get into a little bit of almost calculus type notation, you guys. Okay. So the way that you would read these things in the table, this is notation, and how we read it is we say as x approaches c from the right, as x approaches c from the left. Okay. This one says as x approaches infinity, as x approaches negative infinity. Okay, so you really want to think of this as we can travel the graph one of two ways. For these two, you're going to be traveling inward on the graph, not outward. And then for these two, whenever you see an infinity, you're going to be traveling outward. Okay, and we'll talk more about that in a second. Okay, when we get to like this first example, the inward versus the outward. Okay. All right, so let's go take a look at, and another, well, by the way, another way to think about these two is these two are vertical asymptotes. Whereas these are, if there are any, horizontal asymptotes. If there are any, okay. So let's go take a look at this notation, this new notation, okay. So these first two are as x approaches the infinities, positive infinity and negative infinity. We said you want to be thinking about traveling outward, not inward. And then these two are as x approaches a constant, right? Well, that means we want to be traveling inward. So what I mean by that, this would be me traveling the graph outward. I'm going away out towards infinity, right? Okay. The opposite of that would be me going on that same curve, but going inward, going this way. Okay. So whenever it's the infinities, like these guys are, you want to be traveling outward along the graph. So I want to be going this way because it says as x approaches positive infinity. So I'm going to be traveling out towards the right. Now, why is this positive infinity? If the x-axis kept going, maybe 100's over here, I'm just going to keep going. And you can see that I'm heading towards bigger and bigger x values, right? In other words, I'm heading towards infinity. Now, the question is, we already know what the x values are. That's what they're saying here, right? If x is this, if x is this, if x is this, right? But what you want to report out is what's the y? Because remember, f of x is y. So you want to say, okay, what's happening to the y? Well, the y value seems to be getting closer and closer to this dotted line, right? And this dotted line goes through 1 on the y-axis, okay? So we want to say as x goes to infinity, y goes to 1. And you'll notice the other way we described this wasn't just the movement going outward, but we said, think of horizontal asymptotes. Horizontal asymptotes. Okay, well, we do have a horizontal asymptote. Our horizontal asymptote is 1, okay? All right, now for negative infinity, you're still going to head outward, but you're just going to head outward towards the left because we know negative infinity is off to the left when it comes to x, right? And you can see I'm still getting closer and closer to this dotted line, right? I'm just going to keep getting closer and closer to it. Just closer and closer. And so I'm still heading towards the value of 1, the y value of 1. I'm still heading towards that horizontal asymptote. Okay, so those are the cases where we're heading outward. Now let's go ahead and head inwards. Let me erase these marks so that we can see. Now we're going to travel the graph in a different way. I'm going to head inward instead of outward, okay? So this says as x approaches 3 from the right. Well, you'll notice 3 is right here where this vertical asymptote is. So I want to head towards 3 from the right-hand side. So I'm going to take this blue graph and I'm going to head inward on it. I'm going to head towards 3. And you'll notice that as I head towards 3, the y values are getting higher and higher and higher, right? Higher and higher. Okay, so that means that we're heading off to infinity, positive infinity. Now, if I head towards 3 from the left, which is the next question, the little negative exponent would meet from the left. Well, then I'm going to head towards 3, but be on the left-hand side of 3. So I'm heading inward. And you'll notice this time, all of my arrows are just going down and down and down. And I'm getting closer and closer to, as I get closer to 3, my y values are going to negative infinity this time. So you always have to make sure that you're reporting out y values. I get some students that get confused and they'll say, I'm heading towards 3. That's an x value. You know, of course, we were heading towards 3. That was our goal, was to head towards 3, right? You want to report out where are the y values going. So if you look at the y-axis, you can see we're getting lower and lower and lower. Okay. All right. And notice this was the horizontal asymptote. And then 3 was the vertical asymptote, right? Okay. Sorry, you guys, I cannot write. There we go. Okay. All right. So the moral of the story on this page is, how do we find vertical asymptotes? And I'm going to give you a 3-step process, at least for these rational functions, okay, to find vertical asymptotes. Okay. Move it up a little bit. All right, so number 1, factor. Number 2, cancel. And then you'll set the bottom equal to 0. That's our steps. So let's go into these functions and we will do that. Okay, so step 1 is always factoring. So we're going to factor anything that you can factor, top and bottom. Okay, so we have to look for factors of -5. So things that multiply to make -5 and add to make -4. Sorry, the board's glitching a little bit. There we go. Okay. All right, so things that multiply to make -5. Let's see here. It's either -5 times 1 or -1 times 5. It looks like it has to be this one if we're going to add up to -4, right? So those are what we're going to put in the blank here. -5 and +1. All right, so -5 and +1. Okay, so step 1, factor, is done. Step 2, cancel. There's nothing I can cancel. I mean, if this 5 had been a 3 instead, then I would have just crossed those guys off, but he's a 5, so I can't cancel. All right, so then step 3 is to set just the bottoms equal to 0. So we get x equals 5, and we get x equals -1. Okay, so those are going to be where our vertical asymptotes are. I'm going to put this into GeoGebra so you can see what I'm talking about and visually what it is that we are finding, right? Okay, so our function was x minus 3, and it was divided by x minus 5 and x, oops. Okay, so here's our graph. And what you'll notice, let me just make sure I typed it in right. Okay, I did. What you'll notice is right here at -1, there is a big gap there. And I'm going to type x equals -1 so you guys can see right there. Yeah, that's our vertical asymptote. There will be no point on the green graph anywhere along that line. It's just emptiness, right? And then same thing for x equals 5, right? At x equals 5, there's emptiness in the graph too. And that makes sense because when the bottom of a fraction is 0, you get undefined, right? And we just set the bottom of the fraction equal to 0. So we're like, okay, the bottom of the fraction is going to be 0 at these spots, which means the graph will be undefined at those spots, okay? So we call these vertical asymptotes. The graph is going to get really close to it, to the vertical asymptote, but it's never going to touch the vertical asymptote. All right, let's try another one. Now, not a lot has changed, right? I mean, we still have the x minus 3 in the top. They did change the bottom polynomial. All right, so let's go ahead and factor that one. Okay, so we need factors of -3. So things that multiply to make -3 and add to make -2. So let's see, things that multiply to make -3. -3 times 1 or -1 times 3. Looks like that's going to add up to -2. So we're going to go ahead and put -3 and +1 in the blanks. So we're going to put -3 and +1. Now I get some students who factor the bottom and set it equal to 0 and they get it wrong. Remember the steps were factor, cancel, and then set bottom equal to 0. Okay, because if you just set the bottoms equal to 0, you would get 3 and -1. But we're not going to have two vertical asymptotes, okay? So we're going to cancel this, which leaves us with the following function, which leaves us with the following. Okay, so we're going to set the denominator equal to 0, just the bottom, and we get x equals -1. So we should only have one vertical asymptote when I type this function in. So let me go in here and change the denominator. I think it was what, -3? Okay. And then let me turn these off. Okay. So you can see we only have one vertical asymptote this time, and it looks like it's at x equals -1. And that's exactly what we got for the answer, x equals -1, right? Okay, so you want to make sure you cancel. Now, by the way, at 3, what's going on there is that's technically a hole in the graph. Anything that cancels is a hole. So this would imply that there is going to be a hole at x equals +3. So it is something, okay? Trying to think about if they show, yeah, right there. See how it said, now that's what the hole looks like. It's an open circle like that, right? There's no value at that point. Okay, so we do have a hole there. You know what? I should have been taking pictures of these, huh? Let me go ahead and snap some quick pictures, you guys, and I'll put them into the notes so we can see what's going on, okay? All right, I'm going to shrink this guy down a lot, aren't I? I'll put him right here. And then let me go back and get the old one. There we go. And let's go ahead and take a picture of this. Okay, now let's go ahead and do this last one. Let me draw some dividing lines down the middle here. Okay, so on this one, there's no factoring that we can do. We can't factor an x squared plus 25. It has to be a minus, a difference of squares. There is no sum of squares. And so since it can't factor, we would just set the bottom equal to 0. And so we'll square root to get rid of the squared. Don't forget your plus or minus, right? Don't forget to pull the I out, so it's a +25, so we can square root it. So we get plus or minus 5i. Well, that's not going to be our vertical asymptotes. If you have imaginary vertical asymptotes, then you don't have asymptotes. Okay, so imaginary vertical asymptotes implies there are no vertical asymptotes. And that's possible to not have any. Okay, so let's go in here and see what this guy looks like. It was -8 over x squared plus 25, right? Okay, enter. Okay, so you can see, yeah, we definitely don't have any vertical asymptotes on this at all. Let me just do this so we can see the shape a little better. There we go. So no vertical asymptotes, that makes sense. You know, that's what we got mathematically. Oh my goodness, I'm gonna have to really shrink this down, you guys. Hopefully you can still kind of see that. I'm gonna this guy over a little bit. Maybe you're gonna let me select it. Yes. There we go. Okay. So hopefully you feel pretty good about finding vertical asymptotes. We get that 3-step process: factor, cancel, set bottom equal to 0. All right, now let's talk about, we're actually going to do 3 different types of asymptotes today. We're going to do vertical, horizontal, and slant. So now we're moving on to our second type of asymptote, our horizontal asymptote. So here are the rules for it, okay? I'll probably write them in Mecklenburg's language, how I think about it, okay? So here we go. To find horizontal asymptotes. All right, so there's 3 things that could happen, 3 cases, if you will. Oops. When you look at the highest exponents of both the top and the bottom, either there's small bottom, big bottom, or they're equal. So let me make sure everybody understands what I'm talking about. If I'm given any sort of rational function, right? So let's say, I'm just gonna write them over here off to the side. Small bottom would be something like this. Like maybe I have a cubic on top of some sort of quadratic. Okay, that would be small bottom because the exponent here is 3, the exponent here is 2. So that's going to be our small bottom case, okay? All right, and then, of course, for big bottom, you know, maybe you have something, let's say you have a cubic in the top, and then you have like something to the 5th, I don't know, in the bottom. So that would be big bottom because 5 is bigger than 3, right? And then the last thing that could happen is, okay, well, maybe they're equal. So maybe I have like some sort of cubic on top of some other cubic. Okay. In that case, the highest exponents of both the top and the bottom are equal. Now, sometimes they like to mess with you and write your polynomials out of order. So it's not necessarily the first term. It has to be the highest exponent of both the top and the bottom. Maybe they wrote the highest exponent over here in the middle because they wrote it out of order. You just got to be ready for that kind of thing. I don't know. Equal. All right. So in each of these cases, now that we're able to identify them, let's go ahead and talk about. Oh, it won't let me select these. Just hoping it would. A second, you guys. There we go. Okay. So for the small bottom case, there is no horizontal asymptote. For the big bottom, it's always y equals 0. And then if they're equal, you'll just make a fraction out of the leading coefficients. So let me make sure you understand. So for the equal case, this is the one students like because I don't know, it's kind of fun, I guess. But you take the leading coefficients and you make a fraction out of them. So in this case, the horizontal asymptote would be y equals 1/2. Okay. All right, so let's go in and practice this, get really good at it. All right, so the first thing we have to decide is it small bottom, big bottom, or equal? I'm going to look at those highest exponents, right? So it looks like this would be the case of big bottom, right? So for big bottom, it's going to be y equals 0. Okay. The way I like to remember that is, and this is kind of why it is that way. Let's say the bottom of a fraction is really big. Let's say you got like, I don't know, a billion or something. Oops, that's a trillion, huh? Whatever, we'll go with the trillion. Okay. Over that. If you think about, let's say that was, you cut a pizza into a trillion pieces and you gave somebody one trillionth, right? And so your pizza, gosh, these would be the tiniest pieces ever if I had to cut this into like a trillion slices, right? You would be getting basically nothing, right? You'd be getting such a small piece, we might as well call it 0 because it's even smaller than what I just drew, right? Okay. So if you think about the bottom of a fraction being very large, then that means that overall you're getting a very small number that's heading towards 0 if the bottom keeps growing. Okay. All right, so on this next case, is it small bottom, big bottom, or equal? Well, we got a 2 and we got a 2, right? So this is the case of equal. So that means we're going to make a ratio out of the leading coefficients. So we're going to stack 3 on top of 1. So y equals 3 over 1, or in other words, y equals 3 would be our horizontal asymptote. All right, our last case is small bottom, right? Okay, 2 is smaller than 3, so this is small bottom. And in the case of small bottom, there is no horizontal asymptote, okay? And that's because the top just keeps growing and growing and growing. So this number is going to get bigger and bigger and bigger, okay? No horizontal asymptote. All right, the graph of a rational function may not cross a vertical asymptote, but it may cross a horizontal. So some teachers, maybe in high school you heard this, oh, it never touches the asymptote. Well, that's not true. There's plenty of examples, especially in calculus, of functions where the horizontal asymptote is crossed not even once, but infinitely many times, right? This has been crossed so many times, right? It's just going to continue to be crossed, but the horizontal asymptote is 0 still. So a horizontal asymptote is a number that the graph approaches as you head out to infinity or as you head out to negative infinity. Surely it can cross it, okay? It doesn't cross a vertical asymptote though, so maybe that's why some teachers use that language, okay? All right, so there is a question on your test for this section where it says, determine if the function crosses the horizontal asymptote. All right, so if we want to find out if a function crosses the horizontal asymptote, then set it equal to the horizontal asymptote and try to solve. Okay, to see if a function crosses the horizontal asymptote, set it equal to the horizontal asymptote. If you can solve it, the answer is where it crosses. If it has no solution, then it doesn't cross horizontal asymptote. Okay. All right, so first thing we got to do is, what is our horizontal asymptote, right? Well, we can see that this is the case of equal, right? 2 and 2. So this is the case, this is the case of equal exponents. So we're going to make a fraction out of the leading coefficients. So it looks like it's going to be 2 over 1, or in other words, 2. So y equals 2 is the horizontal asymptote. I put HA for that because I get a little lazy, okay? So we have to set the equation equal to the horizontal asymptote. So we are going to take 2x squared minus 4 over x squared minus 3x minus 4. And we're going to set it equal to the horizontal asymptote. We just got to solve this. All right, so we know how to get rid of fractions. We multiply by the LCD, the least common denominator. Well, there's only one denominator in this case, so that has to be it. And that's going to cause the fractions to go away because right now we're going to cross these off. So no more fraction. I'm going to distribute the 2 in. All right. All right, and then we're going to take away and add. Same thing over here. Take away and add. 0 equals, these are goners, negative 6x minus 4. Okay. All right, so then looks like we'll just add the 4 over. Or actually, why don't we add the 6 over? Why not? We'll move the 6 over. Oops, let me do that in black, you guys. And divide by 6. Okay, so what does that mean? That means it does cross the horizontal asymptote. Okay, so, and not only does it cross it, but we know where it crosses it. Okay, so the graph crosses the horizontal asymptote at, let me get this out of the way, at, well, we know the x value is negative 2/3, and we know that the y value is 2 because that's where the horizontal asymptote is. Okay. Let's get a picture so you guys can see what I'm talking about. Okay, so let's go ahead and graph 2x squared minus 4. Okay, so the horizontal asymptote, and let me shrink this down a little bit. I forgot I stretched the x-axis. There we go. So first thing I want you to notice is that y equals 2 really was our horizontal asymptote. Bam, there it is, right? Let me make that a different color. 7s, let's make it blue. Okay. All right. So my horizontal asymptote, you might not be able to tell that it's the horizontal asymptote, but let me shrink down the x-axis so you can really see, oh my goodness, it is approaching that line, right? Look how close it is to that line over here. And look how close it is to that line over there. If I shrink it even more, it just gets closer and closer and closer. Okay. All right, so now we said, yes, the graph does cross the horizontal asymptote. Look right here, right? Right there. And of course the y value has to be 2 because you're saying it crosses the horizontal asymptote of 2. So yes, the y value is 2, but we found out that we know the x value too. We said at negative 2/3, comma 2, yes, that's the point where this crosses it. And it's the only point. I don't see any other points on the graph where we've crossed that blue line. That's the only spot where we've crossed the blue line. Okay. So this point here's like negative 1-ish, right? So negative 2/3, comma 2 is going to be that point right there. Okay. All right. So set the graph equal to the horizontal asymptote. If you get a solution, it crosses. If you don't, it doesn't. Okay, here's our last type of asymptote, a slant asymptote. Okay. So to find the slant asymptote, get some steps here. First of all, let's talk about when it exists. So a slant asymptote exists number one, it exists if the top is 1 degree higher than the bottom. So that's when we know we have one. How do we find it? You either use synthetic or long division, synthetic or long division, and ignore the remainder. So that is how you find it, okay? So let's go in and we'll take a look. Okay. So we're looking at this. It's like, how can we instantly know that we have a horizontal slant asymptote? The top is exactly 1 degree higher than the bottom, right? It can't be like a 4/2. Then we wouldn't have one, okay? So since the top is 1 degree higher, we know we have a slant asymptote. Okay. All right. So let's do some, in this case, we can't use, synthetic, darn it, right? It's our favorite. Since the bottom is an x squared, is degree 2. Okay. So we have to use long division. Okay. All right. So no biggie. All right. Now this one is kind of a weird long division problem because there's a lot of missing terms, huh? We have 3x cubed. We don't have an x squared. We don't have an x to the first, and we don't have a constant. So now we can put our x squared minus 9. And you guys know me, I don't put zeros on the divisor, I only do it on the dividend, but it's your call if you want to do that. All right, so what can we multiply x squared by? So x squared multiplied by what? Would get us 3x cubed. So it looks like we would need another x and a 3, right? Okay, so I'm going to put it right here. All right, 3x times x squared is 3x cubed. 3x times -9 is -27x. Don't forget to change the sign, change the sign. So those cancel, and we end up with 27x. Bring down your plus 0. All right, so now we got to ask ourselves, what would we multiply x squared by? Oh, wait a minute. I think we're done because there's nothing that we could multiply x squared by to make 27x, right, you guys? This doesn't make any sense. So we're done, okay? So forget the plus 0. That's our remainder. So remember, the remainder goes over the divisor. The remainder goes over the divisor. But wait, we said a second ago, I got to remember that I'm doing asymptotes here, right? We're supposed to ignore the remainder, right? Ignore the remainder. So what this means is we have a slant asymptote of y equals 3x. That's going to be our slant asymptote. Okay. So let's go see what that looks like in the graph. Now remember that y equals 3x, if we were to graph it, right? We think of 3x plus 0. It would go through 0, and I'd go up 1, 2, 3 over 1, and I'd have some line. So we're going to see that line right now. I'll graph it in GeoGebra so you can see that that line is going to guide our graph, okay? All right, so let's delete. Okay, so I'm going to graph our asymptote, 3x. And then I'm going to graph the equation, 3x cubed over x squared minus 9. 3x cubed divide, oops, I hit the wrong thing, sorry guys. 3x cubed divided by, I guess I don't need parentheses, x squared minus 9. Okay, so let me go ahead and zoom out a lot so you can see what I'm talking about. Right now you're like, what are we talking about, Michael? All right. Now hopefully you can see. Look at how great that is, right? That line that we graphed, y equals 3x, look how close the graph gets to it, right? And how close the graph gets to it over here. That is perfect, spot on, right? Now it's only going to be close to it out at infinity. It's not going to be close to it in the middle, right? In the middle, it's very off. Out at the infinities, positive and negative infinity, that's where we're going to be close to it, okay? All right, beautiful graph. Okay, so now we're going to go in and graph a few. What do we have here? We got 4 of them that we're going to graph. Okay. All right. So let's just go through and look at what they want us to do. They want us to get the x and y intercepts, find the vertical, horizontal, and slants, determine if it crosses it, right? And then if there's any symmetry, look at that, and then plot points. Okay. Okay. So let's go in and get the x and y intercepts. And we know how to do that. To find x-intercepts, we let y be 0. And then to find y-intercepts, we let x. Okay. All right, so I'm going to go ahead and put 0 in for the y, which means the left-hand side of the equation. We just did one like this. We're going to multiply by the denominator to get rid of the fractions. Okay, whatever you do to one side, though, you got to do to the other. Yikes, this is going to be hard to fit in here. Sorry for the glitch on board. Okay. All right, and so what that's going to do is that's going to cause our fractions to go away because these are going to cancel. And 0 times anything is still 0, so it doesn't even affect the left side. Okay, and that does not look factorable, so we're going to bust out the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Straight piece here. Let me see if I can get them out. Oh my goodness, it wants to take too much. There we go. Here too. All right. Okay, so we've got x equals positive 1. A negative times a negative equals a positive. And I'm going to circle my negatives. I've got 2 of them, which means this is going to become plus. And 4 times 1 is 4, times 5 is 20. So our x-intercepts are at 1 plus or minus the square root of 21 over 2. Now, how you'll put that in is you'll go 1 plus the square root of 21 over 2, comma 0, and 1 minus the square root of 21 over 2, comma 0. So that's going to be your x-intercepts. All right, let's go in here and get our y-intercepts. So we're going to plug in 0. So all of this stuff's going to go away. We're just left with negative 5 over negative 6. So it looks like it's going to be 0, comma, negative 5, 6. So we can at least graph those points, right? Okay, so 0, comma, negative 5, 6. Let's see, we're counting by, it looks like 2's, you guys. So this would be what? Negative 1 right here. So negative 5, 6 might be like right here. All right, and then the other ones, I would need to get my calculator out. Let's see if I have a calculator. I don't. Oh my goodness. Let's see. All right. Let's see if this one will do it. Okay, so the square root of 21 plus 1, and 1 divided by 2. So for these points over here, you guys, I'm getting like around 2.8-ish. That's approximation, right? This is just an approximately. So 2.8, comma 0. And I remember we're counting by 2's, right? So this would be 2. 3 would be like right here. So 2.8 might be like right there. Okay, then for the other one, let's see here. I'm getting negative 1.8-ish, comma 0. So remember, this is negative 2 right here. So this would be negative 1. So negative 1.8 might be like right there. Okay, so that's what we've got so far. All right, now let's go in and get the other things that it wants, okay? So let's go in and get our vertical and then our horizontal asymptotes, okay? We actually don't have a slant. I'm just gonna put VA for vertical. I'll put HA for horizontal. And then I'll just put SA. There we go. Okay, so remember the process is factor and cancel and set bottom equal to 0, right? Okay, so we're going to factor. Now the top does not factor. We already said that. That's why we use the quadratic, right? But there are factors of negative 6 that add up to negative 5. Negative 6 and 1. Let me put this here to make sure everybody knows what happened. There are factors of negative 6 that add up to negative 5. It's going to be negative 6 and positive 1. So there's nothing to cancel. Factor cancel, set bottom equal to 0. So when we set the bottom equal to 0, we'll get positive 6 and we'll get negative 1. So at positive 6, I'm going to draw a vertical asymptote 2, 4, 6. So it looks like it's going to be right here. And then at negative 1, right? So like about right there. All right. Now for the horizontal asymptotes, we can see that we have the case of equal exponents, right? There's a 2 on top of a 2. So when it's equal, you're going to make a fraction from the leading coefficients, right? Fraction from leading coefficients. So there's a 1 on top of a 1. So we would put y equals 1 over 1, or in other words, y equals 1. So I'm going to put a horizontal asymptote through y equals 1. Remember, we're counting by 2's. So I'm going to put it halfway in the, oops, I don't know what just happened, you guys. Let me try that again. Halfway. There we go. Moving down a little bit so it looks halfway. There we go. So that's going to be y equals 1. Since this is 2 right here, right? Okay. Now there is no slant asymptote because the top is not 1 degree higher than the bottom. So I'm just going to go ahead and give me a second to get that thing out of the way. Ooh, where did it go? Did it go away? Oh man, and it comes back. Let's see if this will help. There is no way for me to get rid of that on my Surface Pro. That stinks. Okay. All right. So then, oh man, now that's weird too. All right. So none since top isn't 1 degree higher. Guess we'll just have to do this. Okay. Sorry, my writing's so atrocious, you guys. I'm really trying to. That is my name. Okay. All right. So let me get a picture of what we have so far. And I'm going to take it to the next slide as we continue doing a little bit more. Big God. I don't like them being nice and big like that. Okay. So then if we look at the directions, we got the x and y-intercepts, we got all the asymptotes. It doesn't look like it's going to be symmetric, so I won't talk about that one. All right, now plot points. Okay. All right, so at this point, Connect Math is going to be very specific, you guys. So you need to make sure that you read, because it says stuff like, find at least 2 points on each side of the vertical asymptote. So you'd have to pick 2 points here, you have to pick 2 points here, and you have to pick 2 points here, okay? I'll just kind of walk you through, if I'm not using Connect Math, you know, what I would do, okay? So right now, you know, let's say our vertical asymptotes are what they're at, -1 and 6. Okay, so this is x equals 6. So what I'm going to do is I'm just going to like t-chart. I'm going to pick some to the left of -1. So let's say I pick -2 we've already done. So let me say I plug in -3. And then there's already 2 points here and here. So I'm just going to pick one more and let me tell you my thought process. Right now, it looks like the graph's probably going to go like this, right? I have to see, is it going to continue to go up because that's something that happens? Or is it going to turn around and go back down because that's something that happens too? So I'm going to pick maybe somebody like right in this area over here. So remember, we're counting by 2. So 2, 3, maybe I'll pick 4, you guys. So I'll pick 4. And then what is this? Let's see, 2, 4, 6. This is 8 and this is 10. So maybe we can pick 8 and 10. Okay, that's us getting at least 2 points on each side of the vertical asymptotes. In fact, 3 points there in the middle, which quite often you have to do 3 points in the middle. Okay. Now, what are we doing with them? We're just plugging them back into the original. Okay, x squared minus x minus 5. And I'm going to put it over the factored. You're welcome to not, but what was the factored one? -6 plus 1. I find it easier for me if I plug it into the factored form. That's your call. All right, so this is just us hammering it out. Well, you guys got calculators, right? You're allowed to use those on your tests. So you just plug this into your calculator. Okay, so it's going to be 9 minus minus, so plus 3 minus 5 over -9 times -2. So 12 take away 5, we get 7 over 18. So 7/18 is really small, right, you guys? So 7 divided by 18 is like 0.4-ish. Got 0.38. We'll say 0.4. All right, so approximately 0.4. So at -3, remember we're counting by 2s. So -2, -3 would be like right here. At -3, I'm going to go up 0.4. So I might be like right here-ish. Okay. All right, let's do the next one. I'm going to substitute in 4. So 4 squared minus 4 minus 5 over 4 minus 6 and 4 plus 1. 4 squared is 16. 4 minus 6 is -2. 4 plus 1 is 5. So this is going to be 16 minus 9, so 7 over -10. So as a decimal, -0.7. Okay, so at 4, count by 2, so 2, 4, I'm right there. 4, I'm going to go -0.7, so not even 1. So like maybe right here. So then I think I know what this is going to do. Okay, so far, here's what I'm thinking our graph looks like, you guys. Maybe I'll do it in blue. It's going to look like this. Then it's going to look like this. Okay. So now I just got to plug in a couple points over here to see if it like is up here, if it's down here. It's one of those weird ones that crosses the horizontal asymptote for some reason. Okay. But usually it's either here or here, and you just got to figure out which one. Okay. All right. So I'm going to plug in 8 now. Okay, so let's see here. That's going to get us 64 minus 13, which looks like 51. And this is going to be 2 times 9, which is 18. Let me get a decimal on that. 51 divided by 18, 2.8-ish. Okay, so around 2.8-ish. So at 8, I'm going to go up 2, which is a full square. And then remember 3 is halfway. So 2.8 might be like right there. Okay, so it's looking like it's probably going to be something like this, you guys. I'll do one more because I know Connect Math likes you to get 2 points a lot of times on each side of the asymptotes. So here's my last one, okay? 10 squared minus 10 minus 5 over 10 minus 6 times 10 plus 1. So we got 100, take away 15, which is 85. And then we have 4 times 11, which is 44. So let's see, 85 divided by 44. I'm getting like 1.9-ish. Okay, so 1.9, well, that's still above 1's halfway. It's pretty close to 2, right? So maybe like right there. So here's going to, I'm sorry it's so messy. This board makes me look way messier than I already am. Okay, so something like that. Let's go in and graph this guy and see if we're right. Okay. Alrighty. X squared minus x minus 5. Divided by, I think it was x minus 6. X plus 1. Adjust the y-axis a little bit because it's really too small. And I'm going to adjust the x-axis a little bit. All right, that looks really good for what we got, right? Okay, so at x equals -1, that's where we got a vertical asymptote. And then at x equals 6, there's, that looks great. And then I believe we had 1/1, so y equals 1 was our horizontal. Okay. And look at, we are below. I made a mistake here, didn't I? Okay, so let me go fix that. Did I make a mistake on these points? I think I might have, you guys, because they do not have it going through. Let me double check everything. Do mess up. So I must have messed up on my y-intercept. Yeah, I did. What's wrong with me? Okay, so do you guys see here it's a negative divided by a negative, and I kept it negative? Ay, ay, ay. Okay, so it really should be a positive if it's a negative divided by a negative, right? So that is going to change one of these dots, huh? It is going to change this dot right here. So I'm going to be at positive 5/6, you guys. So that's going to be right here, right? Oh my goodness. Okay. So if we go back to this slide right here, just kidding on this, huh? Right here. That dot is going to be right here. Okay. So we did these 2 dots. We plugged those in. We did those correctly. But it looks like our graph's going up now, huh? Instead of down. Sorry for that one wrong dot, you guys. Something small like that made it go the wrong way, huh? All right. So then this should be up. But other than that, we look really good. We're up here in this quadrant, right? Which is exactly where we should be on our graph. So that looks great. Okay. This one went up, the other side went down. We have that. So aside from just making a little tiny error in my math, I think this looks pretty darn good. Okay. All right. So sorry about this straight point. I can't erase them right now because I did a screenshot of it. Maybe I'll put a little X through it just so we know. Ignore that dot. That was Mecklenburg's error. Okay. All right, let's try the next one. All right, so finding the X and Y intercepts first, right? All right, get a little text box. Sorry, you guys are doing some, we have a leak in our AC. And so they're like tearing down the drywall and then doing that dehumidifier thing. It's a little loud. All right, so to find x-intercepts, let y be 0. To find y-intercepts, let x be 0, right? Okay. All righty. So we're going to put 0 in. for the y value. Move this over a tiny bit just to give me a little space, because we're going to have to multiply by the x squared minus 4 to cancel. And 0 times anything is still 0. And you could probably tell x has to be 0. If you can't, it's okay, just to do your thing. Now maybe you can tell it has to be 0. If not, the square root of 0 is 0, right? So 0, 0 is an x-intercept, which means it's also a y-intercept too, because 0, 0 is both on the x and the y-axis. Okay, I love it when things get expedited like this. All right, so that's going to be the x and the y-intercepts. Let's go do some asymptote talk, okay? So we got to get our vertical asymptote. So we know that's when we do the factor, cancel, set bottom equal to 0, right? Okay, so let's factor. So if we factor x squared minus 4, it's x plus 2x minus 2. It's a difference of squares. We can't cancel anything, so we're just going to set each piece equal to 0, giving us -2 and giving us +2. And let's see what they're counting by. Are they counting by 2s again? No, 1, 2, 3, 4, 5, 6, 7, 8. They aren't. Okay, great. So 1, 2. Okay, so I'm going to put a vertical asymptote at 2 and at -2. All right. All right, now let's go in and get our horizontal asymptotes. So remember, small bottom, big bottom are equal. We got to figure out which one of those it is. It is the equal case, right? So we're going to make a fraction out of the leading coefficients. So we are going to put 2 on top of 1. 2 over 1 is just 2. So at y equals 2, we're going to have a horizontal asymptote. There we go. Now, by the way, you'll never have both a slant and a horizontal, okay? Because if the top is 1 degree higher than the bottom, then it would be a small bottom, and you wouldn't have a horizontal asymptote, right? Small bottom means no horizontal asymptote. So it's an either or situation, right? Either you have a horizontal or you have a slant. You can't have both. Maybe you have neither, okay? But you will not have both, you guys. Okay, so we're going to go ahead and write in here, the top is not 1 degree higher. So no slant asymptote. Okay. All right, so we've got that. So now we're going to go in here and we're going to t-chart. Now, by the way, something to notice is this is an even function. All of my exponents are even. Let me just write it out and make sure that that's clear. Remember, behind every constant, there's also an x to the 0 power. So this would be an even function since every exponent is even. So that implies it's symmetric to the y-axis. That was our last chapter, right? You guys, even functions are symmetric to the y-axis. So we can basically get away with doing one side and the other side will come as a freebie. So what I mean by that is, let's say you found out that the graph looks like this. Well, then you know the other side of the y-axis is a mirror image, so it'd have to look like that. Okay, so we can get away with just t-charting the one side, and that'll be good enough, okay? So let's go ahead and do a t-chart. Some good values to pick would be 1, and then maybe a couple over here, like 3 and 4. That's just because I know Connect Math is going to say, hey, get at least 2 on each side of the asymptote, right? All right, so let me plug 1 in. I'm just going to like do it and then erase it, you guys, because it's starting to get a little cluttered. This is the ugly work that, you know, you were just doing your calculator anyways. All right, 1 times 1 is 1, 2 times 1 is 2, 1 times 1 is 1, 1 take away 4 is -3. So -2/3, you guys, is going to be here, which is about -0.67-ish. Okay, so I'm going to go to 1 and -2/3, so like right there. All right, and then when I plug a 3 in, three squared is 9, 9 times 2 is 18. 3 squared is 9, 9 minus 4 is 5. So 18 over 5 is what? Goes in 3.6 times. Okay. All right, so I'd go to 3 and 3.6. So about right here, you guys, because this is where 3 is, and this is where 3 is, and this is where 4 is. So 3.6 would be like right there. Okay, and our last one is plugging 4 in. So 2 times 4 squared over 4 squared, take away 4. 4 squared 16 times 2 is 32. 4 squared 16. 16 minus 4 is 12. Which if you divide by 4, you get 8 over 3. Which is 2 2/3. So like approximately 2.67. All right, so let's see here. 4, and again, I'm just doing this because you guys have calculators. You can have them tell you. 2.67. So 1, 2, 2.67. All right, so here's what I'm seeing for our graph. I'm gonna do it in blue so it kind of pops. We've got something like this going on, and we've got something like this going on. So what that means is, since we have a mirror image, symmetry to the y-axis, that this has to happen to have that mirror image, and this has to happen, right? These two dots, wherever they are, I would probably draw that a little better. Let me put those dots in, you guys. So this dot is a mirror image, and then this dot is a mirror image. So hopefully you're seeing these two dots reflected over there. And now I can draw an even better graph. All right, so we use symmetry to shortcut the process. Anytime you have all even exponents, you know you're going to be symmetric to the y-axis. Let's see how we did, because no, last time I did mess it up. So let's go see what's going on here. All right, 2x to the second divided by, I think it was x to the second minus 4. Okay, oh my goodness, we did such a good job, you guys. That is, I don't have my asymptotes put in there, but that is exactly the graph we had. If I put in x equals 2, x equals -2, y equals 1, I think it was. Oh, look at that. That's fabulous, you guys. So if you go back and look at our graph, it's exactly what that guy looks like, right? Spectacular. Oops, it was y equals 2. That's the vertical asymptote. Just kidding. I always think I remember and I don't. There we go. That's even better. Okay. All right. So it looks very good. Let's try number 12. All right. So this, let's see, we need to get our x-intercepts and our y-intercepts. So I hate when they count by weird numbers. I think it's hard on people to understand it. I might change those, you guys. Give me a second to get the details, but oops, y equals 0. Why am I typing 2? I don't know. Okay, actually y-intercepts. There we go. Okay, I'm thinking I'm going to count by ones. I mean, I think it should still get the job done. 1, 2, 3, 4, 5. 1, 2, this will be -3. And this will be -3. 1, 2, 3. Okay. All right. So I'm going to go ahead and substitute 0 in for the y. I'm going to move this guy over. So if we substitute 0 in for the y, we're going to be multiplying by the denominator of x minus 3 to make those cancel. Whatever you do to one side, you got to do to the other. 0 equals 2x squared minus 8x plus 8. I'm going to factor the 2 out or divide the 2 out, however you want to look at it. And you could just get rid of them by dividing them away, right? So he's irrelevant. All right, so we have to look for factors of 4 that add up to -4, right? Factors of 4 that add up to -4. -2 times -2 is +4, but -2 plus -2 is -4, right? So it looks like this guy is going to factor as x minus 2 and x minus 2. So of course we get x equals 2 as a intercept. So we're going to go to 2, 0, and we're going to put a dot. All right, then for the y-intercepts, we have to let x be 0. And I want to make sure that you guys, just understand all the things with x's in it are going to go away because you're plugging 0 in for them. So just the 8 over -3 will survive. So 0, -8/3 would be where we would have our y-intercept, which -8/3, if you want to put it into the calculator, 2.67, so -2.67 approximately. Don't put that into Connect Math, that would be wrong because I rounded. So 0 and -2.67, so like maybe about right here, you guys. All right. Okay. This is not a point. Maybe I should just put an X through it so you guys know. So that's going to be -3 on here. Okay. All right, so we have 1 point or 2 points on our graph, right? 2, 0. All right, so now we're going to go for our asymptotes, right? So for our vertical asymptotes, we're going to factor, cancel, set bottom equal to 0. Well, we've already factored the top. Remember that x minus 2 and that x minus 2 that we did over here? Okay. So that's the top, and the bottom is just x minus 3. So nothing can cancel. It's not like I can cross those off, right? So factor, cancel, then set the bottom only equal to 0, right? So x equals 3 is going to be where our vertical asymptote is. So right there. All right, now let's go in. Now we don't have a slant asymptote. I'm sorry, we don't have a horizontal asymptote because we have the small bottom case, right? Look at our exponents. This one's a 2, this one's a 1, okay? So since it's the small bottom case, no horizontal asymptotes. All right, then for the slant asymptotes, they exist if the top is 1 degree higher, and that's exactly what we have. So we know it exists since the top is 1 degree higher. So we need to do division. So divide and ignore the remainder. All right, and we could do synthetic division because the bottom is linear. So if x minus 3 is set equal to 0, then we would get x equals 3 that's going to go in the box. 2, -8, and 8 are the coefficients. Bring down the 2 to get the ball rolling. 3 times 2 is 6. 3 times -2 is -6. And who cares? Because we're going to ignore the remainder anyway. So I didn't even really need to find that, you guys. Bam. So if we write this out, this is going to be the line y equals 2x take away 2. That's going to be where our slant asymptote is. So -2 is the first dot. And then I'm going to go up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1, etc. And I might keep these going. Let's go ahead and draw the slant asymptote. Okay. And then I'm going to make my vertical asymptotes just to start this bit longer. Okay. All right. So now we know that we have something like this going on in this area right here. And what happens with these slant asymptotes, right? Let's say you have a slant asymptote, so a vertical and a slant. It is always, if this one is here in this quadrant, then that one's there in that quadrant. They're always opposite of each other. If you have one here, then the other one is here. Okay, so if I'm looking at this one, I automatically know, because this one's in this quadrant, that the other one will be up here in this quadrant. Now on Connect Math, you might have to get some points and stuff, but I'm just letting you know kind of the shortcut that we know it's going to look something like this, okay? We do have 2 points on the left-hand side of the vertical asymptote. Knowing Connect Math, I'd want 2 points on the right-hand side. So if I were to t-chart this, because I had to, because Connect Math would make me, then what I would do for values is I'd probably pick 4 and 5, you guys. So if I pick 4 and 5 to plug in, let's see what we end up getting. Okay, just do the math here. So I'm going to plug a 4 in. Okay, so we got 2, 4 minus 2 is 2, 4 minus 2 is 2, 4 minus 3 is 1. Sorry. 2 times 2 times 2 is 8. 8 divided by 1 is 8. So you would get 4, 8. So we'd be way up here at 4, right? We'd be at some value 8, which is not even on our graph anymore, right? 6, 7, 8. We'd be way up here, kind of where we are. Probably about right there. Okay, so we're looking really good. And then you would plug 5 in, do the same math, right? So notice I'm using the factored version. It's much easier to do the math on the factored version than it is on the original, in my opinion. All right, so we get 2, 5 minus 2 is 3, 5 minus 2 is 3, 5 minus 3 is 2. We can cross these 2's off. 3 times 3 is 9. So 5, 9 would be another point. Now, the reason I get these points is, you know how Connect Math works. There's that little box for plotting a point that looks like that. You'll click on that and you'll just type all of these points in. And that's what's going to help you get your graph going, okay? And notice I got 2 points. I got this point and this point, which are on the left side of the vertical asymptote. And I got 4 and 5, which are on the right side of the vertical asymptote. So we are good. Okay. So this one says to use transformation. So in chapter 2, we did learn the graph 1 over x. So let's just remind you, 1 over x, it went through 1, 1, and it went through -1, -1. And I only had you memorize those 2 points, and it looked like this, just the basic shape, okay? So I'm going to graph that on here. I'm going to graph it dotted so we know it's not the final answer, though. Okay, so dot, 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 dot. And so what they want us to do is they want us to use that graph, and they want us to see what transformations would be done to it. So remember, anything inside is lying, and it moves it left or right. Since it's lying, negative you would think would mean to the left, but we're going to go 3 to the right. The back end is telling the truth. Whatever it says, you do exactly what it says. So -1 is going to mean down 1. So the back end gives us the up and down. The one that's inside the function gives us the left and right. So we're going to go 3 right, down 1. So 3 right. Ready? 1, 2, 3, and then down 1. 1, 2, 3, down 1. And by the way, I like to move the axis too. The origin, 1, 2, 3, down 1. That's going to be the new origin. And why that's important is because there is a vertical asymptote and a horizontal asymptote at the origin, which means we're going to need a vertical asymptote and a horizontal asymptote at the new origin. So it's almost like you took the XY axis and you moved them two, right? You just picked up these two axes and you went right 3, down 1. And here's where the new axes are. So now I'm ready to kind of, fake it, if you will, but it's going to be pretty spot on. There is our graph, the blue. It's not dotted, which means it's the final answer. I just realized we didn't check our last one. It would probably be good to see what this looks like, this slant asymptote, right? On a real graph, not my really ugly. Okay, so it was 2 times x minus 2, x minus 2. All of this was divided, oh, dang it. So just kidding, parentheses. There we go. And then that's going to be divided by, oh my gosh, I forgot the bottom of this. I think it was x minus 3. It was x minus 3. All right, so enter. I'm going to put in the asymptote we got, which I believe was 2x minus 2. Oh my goodness, it looks so good. And then x equals 3 was our vertical. So you can see the shapes compared to ours is pretty close. Let's see if I can make it look even more close, like that, right? Okay, so something like that. And again, if it's in this quadrant, then you know where this x is? It's going to be in the opposite quadrant. So this looks really good. That's what we have. We have this red one up here and this red one down here. Of course, I didn't have enough space to draw more of it. But if I were going to be drawing more of it, it would look more like what you guys see, right? In the picture that you guys see. Okay, so that one looks great. All right, let's go check this one out. So 1 over x minus 3 minus 1. Okay, so let's see if it looks like the blue that you guys see here. 1 over x minus 3 minus 1. Oh my goodness, it's perfect. We have a vertical asymptote at x equals 3, just like on ours, right? We have a horizontal asymptote of -1. I put him in. There he is. Let me put the vertical in. Great. And look, it goes through 4, 0. That's my x-intercept. We're going through 4, 0. That looks really good. Okay. So we can use transformation sometimes if we get one that looks like this, as long as we remember this guy, right? That what 1 over x looks like. It's easy to drop those out if you don't use them often. All right, so here's an example of a horizontal asymptote, okay? Young's rule is a formula for calculating the approximate dosage for a child given the adult dosage. For an adult dosage of D milligrams, the child's dosage can be calculated by blah. Now, this is actually something you could use. Like sometimes I don't have like children's Motrin or children's whatever medicine, but I have the adult version. So I could technically use this, right, to get, how much I should be giving my child of that. Okay. Now it says it only is good for 2 to 13, and that's because that's kids, right? You're probably not going to give a kid under 2 any of the adult medication. So for a 2 to 13-year-old. So the first question says, what is the horizontal asymptote? Well, you can see if I have a function like this, so this is right. Okay. The exponents are 1s and 1s, right? A 1 here and a 1 here. So this means it would be the case of equal. So I would have to make a ratio out of the leading, or make a fraction out of the leading coefficients. So there's a 1 here and there's a d here. So it looks like d over 1 would be or in other words, y equals d, would be the horizontal asymptote. Okay, so D is the adult dosage, right? D is the adult dosage. So what does it mean in the context of this problem? If my horizontal asymptote is D, right, then what's going to happen is the children's dose is going to, and by the way, there's a vertical asymptote here. The children's dose is going to approach that as we go more and more towards the right. Okay, so that makes sense. As a child gets older, right? This is their age in years. So you've got a 2-year-old, got a 3-year-old, you got a 4-year-old, whatever. As your child gets older, their dosage should be approaching the adult dosage. Okay, so that's what this means. Okay, as a child gets older, their dosage will approach the adult dosage. Okay. All right. What is the vertical asymptote of the function? Well, factor, cancel, set bottom equal to 0. There is no factoring or canceling that we can do. You're never going to cancel like that. Anything that's adding or subtracting, you guys, never, 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 because we're adding, we cannot cancel, okay? So we're just going to set the bottom equal to 0, which gets us negative 12, right? So this would be x equals negative 12. That would be our vertical asymptote. And that's not even part of the picture, right? I mean, this is only good for 2 to 13. So none of this makes sense because this is negative age. Like, hey, you got a negative 12-year-old, right? So this doesn't even make sense, okay? For an adult dosage of 50 milligrams, what is the approximate dosage for a 9-year-old child? Okay, so we're going to substitute 50 in for the D, right? So if we put a 50 in for the D, this is going to be our new function. Okay, that's letting D be 50. Now we're going to let X be 9 because X is the child's age in years. So we're going to substitute 9 in for the X. If we do that, let's see what C of 9 is. So this is realistic. This is me at home. Man, I have a 9-year-old. All I have is my adult, dosage. Okay, so 450 divided by 21. What is that? Oh, it's a decimal that goes on forever, you guys. So I'm just going to put in approximately 21.42 milligrams. Okay, so if an adult gets 50 milligrams, then the child would get like 21.42 milligrams. Let me just double check my math. Yeah, looks good. Okay, so let's box that. And I want to say that's it. There's just a graph on this last page. Yep, and our graph looks pretty darn good. 50 would be the horizontal asymptote, like we said, because the child's dosage would approach the adult dosage as time goes on, right? Okay. All right, you guys. So that is it for graphing rational functions. Remember to read the Connect Math directions well. Most students miss it because they didn't find the proper amount of points on each side of the axes. And it'll change it every time. Sometimes it'll be like, find 3 points on each side of the axis. Find 2, they'll change it. So you've really got to be looking for that and have your calculator ready. All right, guys, have a great day. Take care.